Good afternoon, everyone. In this topic, we will discuss types of armature windings. So, armature winding is classified as single layer and double layer winding, full pitch and short pitch winding, concentrated and distributed winding. So, we will start with the single layer and double layer winding. Okay. So, see in a figure at the bottom, if a slot consists of only one coil side. Now, in a figure A, a slot is shown. So in the slot there is only single coil side. Okay, so if a slot is consist of only one coil side, the winding is said to be single layer winding. While in a figure B, there are two coil sides are present in a single slot. One coil side is at the bottom and second coil side is at the top. Okay, so this type of arrangement is called as the double layer winding. So if two coil sides per slots, one is at the bottom and one is at the top, the winding is called as the double layer winding. And practically, double layer winding is used in most of the cases, because of in a single layer winding the space is getting wasted. Okay, so this is the explanation of single layer and double layer winding. In a single layer winding, there is a only one coil side per slot, and in a double layer winding there are two coil sides placed in a single slot. Okay, now next is full pitch and short pitch winding. Now first is a full pitch winding. So we know one pole pitch is the center to center distance between two poles, that is 180-degree electrical, as we have discussed in the last lecture only. So, the value of n, that is slots per pole, indicate how many slots contributing 180 degree electrical phase difference. So, coil side of one slot is connected to the coil side in the another slot, which is one pole pitch distance away from the first slot. Then the winding is said to be full pitch winding. Okay. Now, the meaning is what? See, observe in this figure. First figure is showing a full pitch winding and second is showing a short pitch winding. So for full pitch winding, if you see, a coil side 1 is connected in slot number 1 and coil side 2 is connected in slot number n plus 1. So between these two slots 1 and n plus 1, the difference is of n. Okay, so if we consider 2 pole 18 slots armature, then the n is equals to 9, 18 by 2, so n is equals to 9. Okay, so there are total 9 slots in between slot number 1 and slot number 10. Okay, so if a first coil side is connected in slot number 1, then the second coil side must be connected in slot number 10, and in between these two slots there must be a gap of n slots. Okay, that is the 9 slots. So if like this distribution is there, coil is called as the full pitch coil. Now we will see the short pitch coil. See, in a short pitch coil, the coil side of a one slot is connected to the coil side of the another slot, which is the coil span slightly less than the pole pitch, that is the less than 180-degree electrical. The coil is called short pitch coil or the fractional pitch coil. So again the same example, that is 2 pole 18 slots armature. The pole pitch is 9 and we have to made a short pitch arrangement for this. So if the coil side in a slot 1 is connected to the coil side in slot number 9, then the coil is said to be short pitch. Okay, so distance between them, now if you observe in the figure, if a coil is connected in slot number 1 and a slot number 9, then the distance between them is less than n. The distance, the slots in between these two slots are 8. Okay, and this is less than the n is 9. So our arrangement is called as a short pitch coil. Okay, see in the figure they have shown, we have shorted our coil by one slot. Now, what are the advantages of short pitching? Now, first advantage is by short pitching of coil, the length of the coil is reduced. The required length for end connection of coil is less. That is, the inactive length of the wire is less, so less copper is required, and hence it will be more economical. The second is short pitching eliminates the high frequency harmonics which distort the sinusoidal waveform of EMF. Okay, so it eliminates the harmonics also. And third is, as high frequency harmonics get eliminated, this harmonics get eliminated and the waveform will be highly sinusoidal, then ED current and hysteresis loss, which is depends on the frequency, will also get minimized. Okay, so these are the three advantages of short pitching. Now next is concentrated and distributed winding. Now we know in case of alternator we have three phases. Okay, so there are three different sets of winding, each for a phase. So depending upon the total number of slots and number of poles, we have certain slots per phase available under each pole, and it is denoted by M. Now try to understand what is M. So M is equals to slot per pole per phase. Slot per pole is N. Okay, and per phase, how many phases we are having? We are having three phases, so N by 3. Okay, so M is equals to N by 3. Again, consider the same examples of two pole alternator with the 18 slots. So N is equals to 18 by 2, that is 9, and M is equals to N by 3. So it will be 9 by 3, that is 3. So 3 slots per pole per phase is available. So meaning is that the 3 slots are available for R phase, 3 slots are available for Y phase, and 3 slots available for B phase. Okay, so if we are using these 3 slots, okay, all 3 slots for placing R conductor, R phase conductors, okay, then our winding is called as the distributed winding. But if I am using only one slot to place all my R phase conductors and remaining two slots I am keeping empty, okay, then that type of coil is called as, or that type of arrangement of coil is called as concentrated coil. So read the definition. In a concentrated winding, all conductors or coils belonging to the phase are placed in a one slots under every pole. Okay, so it is concentrated coil. Again, we are having 3 slots available for R phase, 3 slots for Y, and 3 slots for B. So I am not using all 3 slots available for R. I am placing all R conductors in a one slot and keeping the remaining 2 slots empty. So that arrangement is called as the concentrated coil. And what is the distributed type of arrangement? That all conductors, suppose X conductors per phase, is distributed the all slots available per pole per phase under every pole, then the winding is called as the distributed winding. Means I am using all the three conductors for R phase, then all the three slots for R phase conductors, then remaining 3 slots for Y phase conductors, and then next 3 slots for B phase conductor. Then my coil is called as the distributed coil. Okay, so this is the complete explanation about the types of armature winding. So it consists of single layer, double layer winding, full pitch, short pitch winding, concentrated and distributed winding. Thank you.